we have a session from Glenn Hopper on AI use cases, AI/chat GPT use cases for finance. I've heard him speak a couple of times on this topic, and I've always loved some of the use cases that he brings to the table. So we really wanted him to come back for this. And Glenn literally just came out of another webinar and he's walking into another one. So I don't know how Glenn generally does this, but yeah, that's Glenn for you folks. Glenn, over to you.
Hey, thank you for the introduction. And I'm, the funny thing is I'm doing all these webinars, and it's not because I'm the least bit interesting or exciting. It's because the topic is so exciting. And I do think, we'll go through and talk about this today, but it's moving so quickly that whatever we talk about today is going to probably be outdated in 2 weeks. So I thought for today, we could stay focused on, I want to do like a high level talk about, this is what AI is, this is why you need to understand it. And then we can talk about some use cases. And if there's time at the end, there's with all that, like with the new GPTs are a perfect example that were rolled out from OpenAI last week. I mean, there are so many opportunities now. So, we've got the prepared presentation. So feel free as we go, though, from the time we put this presentation together to today, there's already new and exciting stuff to talk about. So I'll let you sort of guide a little bit if we want to update what we're talking about a little bit as well.
Do you want to change slides?
Actually, yeah. So I can go ahead and dive in here. So on AI, machine learning, and deep learning, and this is for some of the audience, this may be pretty clear already, but these are words that are just getting thrown out these days, and people use them interchangeably. People use them sometimes incorrectly. And what I wanted to, so I always say this, I don't need to understand how this microphone works to be able to use it. I don't need to understand what's going on behind this super thin monitor screen that I have to understand how the picture comes in. And those are passive things, or I'm just receiving information. So at the risk of sounding a little pedantic or trying to tell finance and accounting people, hey, you need to get a whole new skill set, I firmly believe, no, we don't need to get a whole new skill set, but these tools are so not yet. I mean, everybody's talking about them. We're kind of at the peak of the Gartner hype cycle, but they're about to be as pervasive as anything in the internet. So I urge everyone to take a minute and understand what we're talking about with artificial intelligence, machine learning, deep learning, LLMs, chatbots. What is all this? Because a lot of times right now, if you talk to people and say, what is AI? The first thing that comes to mind for them is ChatGPT or Bard or Claude or whatever those are. And that is a subset of a subset of a subset of a type of artificial intelligence. So to kind of level set when we talk about artificial intelligence, this Venn diagram here, artificial intelligence in general is the broad field where it's a division of computer science where people are trying to use computers to mimic human thought, to do things that historically we have always thought requires a human to do. So the broad field of AI, and that can include everything from a spam filter on your email to a self-driving car to the chat GPTs that are out there to even like rule-based chatbots that were popular 10 years ago on websites. That's all attempts at artificial intelligence. They all fall in that field. The most exciting field or the biggest change really since the Turing in the early days of AI was the ability to have the compute power and the data needed for machine learning, which is a subset of artificial intelligence. And machine learning is a subset of AI that has these algorithms that are blank slates until you start feeding them data, and the algorithms actually learn from the data that you're feeding it. And that has really opened up the world of what artificial intelligence can do, because if you're trying to replicate human thought on a rule system, I mean, there are so many variances and so many different ways you could go. You could never come up with all the rules for it because it's not that linear, and they're just, every branch has branches. So it gets to an infinite problem. But if you have an algorithm that can learn And we talk in artificial intelligence in two ways. There's narrow AI, and then there's general AI, which everybody says we're working towards artificial general intelligence, but that is general broad AI can do everything. Narrow intelligence does one thing very specifically very well. It could be that self-driving car. It could be identifying, reading X-rays to identify lung cancer. These are all just very narrow scopes, and those are types of machine learning that are trained on these massive data sets. So you feed an algorithm a bunch of X-ray pictures and train it on being able to identify, a cancerous area, and then the tool knows how to do that. And we're already seeing, and have been for a couple of years, where AI is doing that better than humans are. So, and then really interesting subset within machine learning, and this is, it blows people's minds. And if you really get deep into it, it's really just a lot of calculus. You've got propagation and everything that goes behind it, but we don't really need to understand all of that. But just within machine learning, there is a type of algorithm. And actually, if we could jump to the next slide, we can maybe make this a little more clear. So in machine learning, I think about it does two things. And this maybe is a better way or an easy way for you to frame it in your mind. If it seems like, oh, machine learning it's doing everything. I don't understand. Is it conscious? Is it trying to think like people do? And I would say you can divide the vast majority of what machine learning does into two categories: regression and classification. So regression is prediction. It's taking, whether it's time series data, just historical data, a series of information, and saying this is the trend. And you could use regression. There's other methodologies you can do to forecast, but it's saying, let me take this information historical and predict what's going to happen next from it. And then the other thing that machine learning does is classification. And it's saying, give me all this data, give me 100,000 pictures of cats and 100,000 pictures of dogs. And then when I feed a new image into it, it's been trained on enough data that it can differentiate between a cat and a dog. So even these artificial neural networks and even ChatGPT and these LLMs, that's what they're doing. So if we go to the next slide, keeping regression and classification in mind, this is what I wanted to jump to talk about machine learning and the way we have done it and what deep learning can do. And these deep learning models, as compute power gets more and more powerful, we're able to add more and more layers, and these get more powerful. And that's why we're seeing the results we're seeing today. But the most common or the easiest type of machine learning was supervised learning, where I took those pictures, here in this example, it's a picture of a car. I go through and I identify on these pictures, this is a picture of a car, and label it however I'm going to label it. And so then the image and the labels come in, and then the machine learning algorithm classifies based on the data that it's fed. And then when you feed a new image to it, it's able to say, okay, well, I've seen enough pictures of a car to know that's a car. So I'm doing my classification there. Now, in deep learning, which is it's built on artificial neural networks, which are modeled after the human brain, which is, you have this input layer, and then you have all these processing layers that are modeled after human neurons in the brain. And this is where all this magic kind of black box calculus happens. And then without labeled data, when the output comes out the other side, you identify it there, and the artificial neural network, the deep learning algorithm, learns to go backwards through based on what you've said and correct the path and be able to identify this information. And so within deep learning, the massive abilities that we're seeing out of these large language models, they're actually, they're a subset of a subset. There's generative pre-trained transformers are a subset of, in the interest of time, we won't dive into that. But ultimately, in that Venn diagram we were looking at the bottom, is these LLMs, which ChatGPT is even a subset of the LLM, because the large language models are doing predictive text. And then to make the ChatGPT and these chatbots, you have to add another level of training that lets them interact with humans, so that it's not just predicting the next word, it's answering questions. And on another session, we could get into how those are trained. But I thought this is a great example of, if you want to know what ChatGPT is, just ask it. And it's not answering. It is important. I always have to remind people, it's not answering this as if it were a conscious thinking being. It is answering based on what series of words are most likely to come up next in a question like this. So when you train a model on literally trillions of parameters, trillions of features, and billions upon billions of words that come through basically from reading the whole internet, you have this model that's been exposed to a lot. It's been trained and fine-tuned enough that it can pick the statistical probabilities and give you answers. And these models are only getting better and better. And I just saw on the news yesterday, they're already OpenAI is already training GPT-5. So typically, I think it's like a 12 to 18 month development cycle. But with everything rolling out so fast, maybe they'll have a new version out sooner than later. So that was, man, I just spit out a whole lot there. So I'll pause, Nivas, and if you have any questions and you want to talk about it, we can, or I can start talking about, specific finance use cases.
No, I don't want to be the interferer to really cover this, right? Like I think a lot of people are looking forward to this. This is the core part. So let's dive in, Glenn.
Okay. So this 2x2 matrix that came from Harvard Business Review, this has become, it's almost like my disclaimer for now. And we've talked a lot, I'm as passionate as they come about where AI is going and what the potential is. I do think right now we need to understand what is capable, what's out there, but we also need to understand that it's not perfect yet. Like I said, these models can hallucinate. If you're doing something that's high stakes, it's you want a lot of caution before you're doing something. And then there's data security issues, data privacy. So we want to be really thoughtful about what information we're putting into these large language models and how we're using the data that comes out of them. So this 2x2 matrix, I think, is a great sort of mental checklist if you're thinking today about using generative AI for something. So on the left side, we have the demand matrix, which is, it's either something that's really high demand or it's low demand. And then on the other axis, we have the risk, low risk and high risk. So, something that would be low demand and high risk is the last place you want to start with. What am I going to ask ChatGPT to do for me? So, medical advice. Am I going to ask any tool on the internet to evaluate my health condition or make, medication recommendations? I would say the risk there is high and the demand for that. I mean, we all hate going and sitting in the waiting room at the doctor, but I think versus trusting, a large language model to do it, that would be low demand, high risk. Now, what is ideal to be messing around with right now with these, I say messing around with, I don't say that flippantly. I think using these tools, understanding how they work and understanding how they're getting better and really using them a lot to identify use cases for them is important. But I'm using them maybe today more as parlor tricks than as something I'm actually using in my daily workflow. But it's coming so fast. I mean, in 6 to 12 months, there's going to be plenty of tools out there, and it'll be incorporated into software that's already out there where we're using this. It'll just become the norm. But for right now, I say take things like, I don't, marketing people may disagree here, but I would say like marketing copy. Yeah. If it's not the best marketing campaign in the world, it's not great. And it's a misspent marketing dollars, but it's not a life and death thing. It's not going to kill the company. And, things like copy editing, code reviews are great. These tools are actually really good at reading and writing code. So if you want to QC some code you've written, that's one. Ideation, these things are incredible at coming up with names, headlines, outlines, things you want to write about. I wouldn't I think that those of us who write a lot, we wouldn't be ready to just give over our writing style and brand to these. But if it's low impact and low risk, if I had to put together a glossary for something, I'm not going to spend a lot of time on that. I'll let ChatGPT or Bard put a glossary together for me. So just think about how and where you're using the tools. And now we can start diving into some specific use cases. One thing that I will say with these is many of us have used RPA and we've been pretty frustrated with RPA. When it works, it's amazing, but it's so like, and RPA, for anyone who doesn't know, is robotic process automation. And the idea is with these, whereas AI is learning from data, RPA is like a rule-based system where you point somewhere on the screen and you say, okay, this box needs to be filled in, and then you click this, and this is the workflow. And if you've ever watched an RPA application run, you actually see the mouse running around the screen like there's a ghost human doing all this work. I think what we're doing with RPA today, 100% of that in the next 2 years will be replaced by generative AI, because whereas that is rule-based, generative AI can take all this information in context, process it, and then have an output and move down. So you could have these workflows. So if something, if it was invoice processing and the address was in a slightly different place, it wouldn't break the system like it does with RPA. It would actually know, okay, this is an address. I've seen enough addresses. I know that's what this is. So think about how this would work with a generative AI tool. You would receive an invoice. It's either a digital invoice that comes in, or some people may be still getting paper invoices, but you digitize it, use OCR, to read and figure out what the words on the invoice are. And then instead of having RPA or having a person do this, the data can all be extracted, labeled, identified, and then entered into the company's accounting system. Once you train this, and once the technology gets there, I mean, I'd say there's tools out there today that could do this. The question is, if you're trying to make this decision to implement it, do you have the ability to build this in-house? Are you going to trust a brand new startup to do it? Or are you going to wait on the big software companies to do it? But basically, no human interaction to get invoice from inbox all the way into your accounting system would be a good example of something that generative AI could do. And then AP and AR, I mean, you'll notice when I talk about the use cases today that I'm talking about manual, repetitive tasks, things that don't require a lot of strategic thought, that are just rote. This is how we do this, and we do it over and over. These are the kind of things that in the near future are going to be easy to be replaced with generative AI. So AP and AR, matching invoices to purchase orders. You don't even need artificial intelligence to do this, but if you have generative AI in the loop, I mean, you matching invoice amounts and matching it to purchase orders and invoices, that's easy enough. But when you have a tool that can read the information that comes in on the invoice, and maybe there's a discrepancy between what was on the purchase order and what was on the invoice, artificial intelligence could identify that used to take a person, spit it out to you. And if it were incorporated into your AP system, it could flag before you went to pay an invoice, oh, this was over, but we see here there was change order number. It could pull this stuff out for you, and just making the human part of the job more on solving problems and doing strategic work. Same thing with payments to receipts, verifying invoices for accuracy, and checking the company compliances. These are all things that generative AI will quickly be doing for us. Again, so AP and AR, there are tools out there and have been for a while where you can have a rule-based tool that is, okay, invoice goes out on this date, so automatically we're going to send out the account statement on the day after. Then we're going to send our first reminder 3 days after, and then we're going to change the wording and get more aggressive with our collections. And those are great tools that are out there, not AI based, just rule based systems that go through and automate some of the work for us. But what we can do with generative AI is start creating more thoughtful automation, if that makes sense. So if we have a client that we know is always a slow payer, maybe it changes how it interacts with them, or it flags them to you. Like if the data's in the system but nobody's looking at it, it's just noise out there. We don't know. But when you dig in and you see, oh, this client, one of our biggest clients, but on net 30 invoices, they usually don't pay till like 48 days later. And then, so our cash conversion cycle gets messed up, and we're the expense that we have to fulfill it. But if nobody's doing that analysis because you don't have the staffing for it, well, two things here. One, if you automate sort of the repeatable part of AP and AR, then you have more time to focus on exceptions. But then if you have a system that's integrated and is automatically looking for this for you, and can flag and identify issues before a human could, then you're adding a real level of value. And if you're doing your cash flow forecast and you've got a tool that's automatically going through and analyzing customer payment history by sector, by customer, by geography, by product, whatever it is, making your cash forecast based on this historical data without having to dump it all into Excel or whatever system you're using and doing some kind of regression manually to figure it out. This is proactively identifying, okay, this is the customer payment history. We know they're likely to be late or miss a payment or whatever. And it lets you manage by exception and say, okay, we know this client's going to be late. Let's get the account manager or whoever to start working with the client and finding a solution for them. So let's see, bank reconciliations. This is one, I mean, there are tools out there today. Again, you don't even need AI for it. There's tools out there that will reconcile bank accounts and do a pretty good job. But, if you have a lot of transactions with a specific vendor, potentially it's, it could be hard to match them up, and all the difficulties we run into with reconciliations. But if you had a generative AI tool that could go through, and the 100% matches are easy. That's just a rule. It's okay. This amount matches this one, this date matches, boom, that's reconciled. But then if there's exceptions there, or too many of them, or something comes up, or the dates are consistently off, it can flag these for you. And again, identify, why are we missing this? What happened? And then you're only working with the exceptions. And another thing that computers are better at than people, this has been proven time and again, is fraud detection, identifying potential errors or fraud in those reconciliations. Yeah, and we can move on to fraud because that's its own field, and that's one that's been around for years, and not even using generative AI, but using what I was talking about, these algorithms that are trained on data and can identify, machines are just, they're built for identifying these variances. So if you get a pop-up message from your credit card provider that they suspect fraudulent activity, that is based on machine learning algorithms that have been trained on all this data. So that's a big area that's been around for a while and has proven much more successful at it than humans have been. Okay, and we got a couple more I want to hit. I know we're running short on time, and you can tell I could talk about this stuff all day. But
I actually have one question, right? Like I think this was probably running through the mind for a lot of the folks who were attending the CFO Leadership Council as well, right? Like I think this was a very heated topic during the break, and they were talking about, hey, how can I trust like a lot of these tools with the internal data, and how much can I provide it with, and how much, what's the line that I should probably stop?
Yeah, and that's a great point right now, and one that I do talk about all the time. And it is, I'm saying right now, unless you're on an enterprise platform, unless you have a strong IT group that is cutting edge and you're running your own large language model within your own server or within your own web hosting environment, or if you're, on the, I don't like to talk about specific companies, but everybody knows. I mean, like Microsoft and Azure has an enterprise setup. So if you're within that, do whatever you want because it's enclosed in that environment. If you're using OpenAI for enterprise, do whatever you want. You're in that environment. If you're at an SMB or no matter what company you're in, and you see that the data analysis tool on ChatGPT is really good at data analysis, which it is, don't upload your company information in there if you don't want it to. It's just like I would tell people, don't put your social security number into a random website. And they're doing a lot for security, but they're also using data that is input into the models for training. And I think that this is for experimentation. It's great. We have these great tools, but in the very, but in where it is today, don't put your proprietary information in. But in the very near future, we're going to start seeing more and more. It's either going to be built into products we already know and love, or startups are going to be sufficiently vetted and understood and have their SOC 2, SOC 1 compliance, and we'll know our data is safe. But until then, for right now, use public company data, interact with it, see all these features, and then wait for assurances that your data is going to be safe. And I think there are a couple areas I wanted to hit, but I think it was good that you stopped me and we talked about that, because whenever I talk about this, there's that caveat today. But that's this year. 6-12 months, we're going to see something completely different.
I think the landscape's also been changing pretty quickly, right? Like, I mean, what you, as you mentioned, I think what was there 6 months ago has evolved significantly today, and I think the landscape's changing really fast. And I think now that there are a lot of tools that are building on top of all of this data and functionality, I think we're going to see just leaps and bounds happening in the next few months. Yeah.
So I'll throw out mention of these. We don't have to go into detail because I think people know this and understand this. Machine learning algorithms, statistics are all incredible at forecasting. And I think of like drag and drop and human natural language interfaces that will make forecasting much easier, give people who don't have statistics skills or don't know ARIMA from regression or whatever, give them the ability to do some great forecasting. Compliance monitoring, same thing. If you put all the rules for SEC compliance or audit compliance, whatever it is, and this can go through, know those rules, analyze the financial transactions, and identify the issues ahead of time, and you can spend your time correcting those issues rather than identifying them. That's huge. And I think those are my last two. And we almost, we did stick the landing. We got,
Right.
Yeah.
I don't see any questions coming in. Yeah.
Okay. Yeah. In short of questions, I always encourage people, get out there, try it out. Don't bury your head in the sand on this. You need to understand it, because if you're not doing anything to prep today, by the time it rolls out, you're going to be flat-footed and you're going to already be behind. So your own data maturity is worth looking at. Understanding of the tools that are out there, where they're going, are all. We do have one question I see come in. Yeah.
So we have a question from Ruchi, Glenn. So she asks, are there any recommended AI tools for finance?
I'm on an advisory board for a couple of startups that are doing things here. Even so, and I tell them, I'm not ready to, anything that's in production out there today, I'm not recommending them right now just with company data yet. We're just so early in this. So the tools that are out there, I would say these GPTs that people are building, I've got several out there that people could use as well, but just find public company data, interact with them that way, understand what they can do, and you'll know when these companies are able to pass security and data privacy concerns and everything. And like I said, it will be in the next 6 to 12 months. And there are tools out there that are incorporating it. There's also tools out there that say they're using AI, but it's kind of just a AI washing thing where they're not really using it fundamentally. So, I would say start with your trusted vendors and known sources. Oh, and here's another question that came in, but I don't want to keep everybody long.
Yeah. How is GenAI going to fill in the gaps the current AI-powered automation systems, like say intelligent document processing?
Yeah. So the big piece that generative AI does is it contextually pulls this information, and it can, based on the knowledge, the foundation knowledge that it has, when it sees this new information, it can interpret at a higher level. So, if you're doing document processing, it's not just the OCR. So, if it misreads a letter, or if there's if you're doing paper documents and there's a smudge on the page, it will be able to fill in, what was missing. And then the other thing for intelligent document processing is, I'm not just talking about semantic search, going through looking for it. And I do this all the time, where you can actually, you can interact with the document. You can ask, if you upload a 200-page purchase agreement, and then you could talk to that document as if you're talking to the lawyers who wrote it. There's massive value in that you're not going to get from just, Control F on a page trying to find the keywords.
Got it. Hey, I think that brings us to the end of this conversation. Thank you so much, Glenn, for coming on board, for doing this with Spendflo once again.
Yeah, happy to be here. Good seeing you.